Good evening, everyone. Welcome to this McDonald Observatory live stream with collaboration from with Mount Wilson Observatory. Glad that everyone can join us tonight. My name is Saul Rivera. I'm the online programs coordinator at the McDonald Observatory. I'm joined today with Joe Wheelock, Ryan Contrell, and Tim Thompson from Mount Wilson Observatory, and we're really excited for everyone to join us today. And how about y'all introduce yourselves? Well, kind of to my colleagues. Joe, why don't you get started?
Hi, Joe Wheelock, and I conduct public programs here at the McDonald Observatory, guided tours, star parties, and wear many hats.
Howdy guys, my name is Ryan and I do literally exactly what Joe does. I'm a programs facilitator, so tours, solars, and I help out with these live streams. So behind me is our 16-inch wide telescope, and I will be controlling it and showing you all live views of the sky. If you're wondering why I look like a little ghost, it's because I'm using a special camera called an infrared camera. This is using infrared light because it's practically dark here with the naked eye.
And the ghost theme is very fitting for October. And our special guest for tonight, Tim Thompson.
Oh boy. Thank you. Yes, I'm Tim Thompson. I'm the science director for Mount Wilson Observatory. I'm a physicist retired from about 17 years ago from the Jet Propulsion Laboratory, where most of my work is in astrophysics, atmospheric physics. And the last big thing I worked on was the Spitzer Space Telescope, which was a lot of fun. And here I am, ready to convince you the Mount Wilson Observatory is almost the best observatory in the world, but I don't want to take anything away from my friends at McDonald who will pull the plug on me if I'm not careful.
Revealing the secrets, the behind-the-scenes secrets. Thank you so much for joining us, Tim, and also thank everyone for joining this stream tonight. Tonight's stream is talking about our galactic neighborhood, so just kind of the galaxies, and talking a lot about the Andromeda galaxy and Hubble's work on the Andromeda galaxy and some really cool discoveries. A really cool discovery he did involving that galaxy. But before we go more into it, if this is your first stream that you've joined in, welcome. If this is your 10th or 20th or 76th stream that you joined in, since we've done about those, welcome as well. We have moderators in the chat that are taking questions, so feel free to drop those questions into the chat. They will be answering them. If there's any question that they think will be really cool that will to answer on air, they will pass that along to us. Also, if this stream will be staying on our YouTube channel, McDonald Observatory on YouTube. So if you join in late, want to rewatch it, or just share it, you can do that as well. Also, if just make sure to enjoy and like and share it, and we hope y'all enjoy tonight. Also, and feel free to put in the chat where you're watching from, whether it be in Texas, like the McDonald Observatory, California, like Mount Wilson is, and we really hope y'all enjoy it. Now, have to get some more details about where the McDonald Observatory is, where our telescope is located tonight. So us here at McDonald Observatory, we are part of the University of Texas at Austin. So when you visit our observatory, you're considered to be on site of UT Austin campus, but we're not located in Austin. We're actually very much out in far west Texas, like about 500 miles west of Austin. We have several research telescopes here on site. Being in the middle of nowhere gives us very nice dark skies to do research in. We can do research on galaxies, nebulae, star clusters, you name it. And we have some very historic telescopes here, and even have some smaller telescopes we can use for public programs. If you're come out here to do some public programs, you'll probably be behind our visitor center. We have an amphitheater here, and one of those telescopes you'll be looking through is a 16-inch Ritchie Crichton telescope. We usually have an eyepiece attached to the telescope. You can look through that telescope at different targets. But for tonight, we have a camera attached to that telescope. And that telescope will be looking at different galaxies tonight, very far away objects. So, way back when, we actually didn't know that there were multiple galaxies. We thought the Milky Way was all that there was, and we actually thought these galaxies were other nebulae. So, a nebula in astronomy is basically just a giant cloud of gas, dust, and stars. We thought galaxies were also these type of nebulae, and we thought the Milky Way was basically the edge of the we thought the galaxy, our Milky Way galaxy, was the edge of the universe, and any cloudy thing we saw was still within our own galaxy. And that was until we, well, better yet to go into more detail, that would be for another observatory, the Mount Wilson Observatory. But before we go into like the work done at Mount Wilson to make the discovery, going to pass it over to Tim because, well, how about we backtrack a bit? So, Mount Wilson Observatory is part of the alliance of historical observatories like the McDonald Observatory. This alliance of historical observatories is several observatories, as the name suggests, of pretty old telescopes and observatories that have made pretty significant contributions to astronomy and the sciences. Mount Wilson Observatory being one of them. And Tim works at Mount Wilson Observatory. And Tim, can you tell us a bit about Mount Wilson?
I will indeed be happy to tell you more than just a bit about Mount Wilson. Let me fire up my slides here. Hopefully you can see.
Yeah, let's see. Let me bring those up. See.
Oh, let's see here. I'll bet I have to select. Yes, okay. Now let's see. Technology.
Yeah,
now you should be able
technology.
Now you should be able to see my slides.
Right. Try and see in there. Well, we're trying to get the slides pulled up. If you have more questions about the telescope we're using tonight and the camera, those specs are in the description of our channel.
I want to say, to answer Tippy's question, yeah, I am running the 16 tonight.
Yeah, this is our 16-inch Ritchie Crichton telescope.
It's right behind me.
Did I hit the wrong button? Can you not see my slides?
Let's see. I don't see them popping up in the share option. They weren't there earlier.
Okay, now I hit this and I say share.
Oh, there it goes.
There they are.
There they are.
Okay.
Let me just remove mine to bring up yours. Because sharing is caring.
Oh boy. Are we in good shape now?
Yep, we're good to go.
Oh boy. Well, as you can see from my first slide, Mount Wilson Observatory is the real Magic Mountain. There are 6 telescopes. Okay, 5 for sure, and I'll have to talk about the other one. The 5 old telescopes. Hopefully you can see my cursor. The horizontal Snow Solar Telescope was completed in 1904. The 60-foot Solar Tower Telescope in 1908. The 150-foot Solar Telescope in 1912. All 3, as you can guess from the names, were used to study the sun. Each one of them was the largest and most capable of its kind in the world when it was built. The 60-inch telescope here finished in 1908, simultaneous with the 60-foot tower, and the 100-inch telescope is over here, finished in 1917. All 5 of them were built over the course of 13 years, from 1904 to 1917. You couldn't build one world's largest telescope in 13 years. Today, we built 5. The sixth one is represented by this tiny little dome here, which you might think is kind of outrageous, but there's one here, a couple out here, and two more way out of the field. These are the 6 telescopes of the CHARA array. CHARA is an acronym for Center for High Angular Resolution at Georgia State University. It's the largest interferometer in the world for optical and near-infrared astronomy, by far the largest, and there's no competition at the moment. It's the only instrument in the world that can map the distribution of brightness across the surface of a star. They've been doing research in close binary stars, looking for the difference between stars who have extrasolar planets and those that don't, and they've been studying active galactic nuclei. So we have a real collection of the biggest and best telescopes in the world at their time. The only other observatory in the world that can boast more than one is the Keck Observatory on Mauna Kea, because they built 2 10-meters simultaneously. Otherwise, every observatory, if they have a world's largest telescope, they have one. And of course, the Hobby-Eberly telescope at McDonald Observatory is, I believe, the largest telescope in North America. So yeah, I can hear the chuckling. Keep you guys happy. So I could talk for hours about Mount Wilson. I don't have hours, but I just want to identify our observatory as the place where we discovered our place in the universe. I might say we actually discovered the universe, but discovering our place in the universe is good enough. If you go back to the dawn of the 20th century, about the year 1900, and I've looked at papers published then, people knew the distances through trigonometric parallax to maybe 60 stars, plus or minus a few, no more than 100. A little bubble of stars around us relatively nearby, and that's all they knew. Everything else beyond that was guesswork. So from 1914 to 1918, Harlow Shapley used the 60-inch telescope to discover what the Milky Way galaxy really was. He was the first one to put a distance scale on it, to describe what it looked like, to describe how big it is. And he called it the sidereal universe because, as Saul was suggesting earlier, he thought, and everybody thought, they had discovered the entire universe. That was it. The Milky Way galaxy, as we call it now, was the sidereal universe. And they were all very happy about that, except that Edwin Hubble came along with the 100-inch telescope and found things well outside the universe, which usually means your universe is actually bigger than you thought it was. And so he discovered the rest of the universe and began to lay out its true distance scale. And at the same time, he discovered the redshift distance relationship that leads us to the idea of an expanding universe from an observational point of view. So really, the big fundamental discoveries in cosmology and galactic astronomy were made during the first 3 decades at Mount Wilson Observatory, first 3 decades of the 20th century. And a lot of that has now made its way into popular discourse and is more than just something peculiar to astronomers and astrophysics. And while I'm talking about Mount Wilson Observatory, well, we do have tours, public, private tours. We do have a specialized engineering tour for you gearheads out there once a month. Don't bring the kids and don't bring the spouse and don't bring anybody who doesn't want to get grease on their clothes and count teeth on the gear wheels, because it's really an engineering tour for engineers and technologists. We have concerts, lectures, art exhibits. There are lots of ways to observe through the telescope. You can rent your own time on the telescope. You can go to a public ticket night. There are lots of ways to do, all described on our web page. This is just a screenshot of our web page. And of course, we have historical material in our own biannual publication, the Reflections newsletter. So there you are. That's Mount Wilson Observatory. What's next?
Yeah, it's really nice having another observatory people can visit. And I actually kind of want to check out that engineering tour myself. I know some of my colleagues do as well.
Mhm.
So I'm wondering, what work do you do at Mount Wilson?
Well, as I said before, I'm the science director. I've been there for 44 years. I was one of the people who began the public tour program at Mount Wilson Observatory. And this is me back in 2017 leading a public tour. It was 10 years ago, 2015, when the Mount Wilson Institute, which operates the observatory for the Carnegie Observatories, who owns it. Mount Wilson was the very first Carnegie Observatory, and we operate it for them, and we're sitting on Forest Service land in Los Angeles County. But we have public tours, and I was one of the original tour guides, and here I am doing that. As science director, my job is to find out how to expand the scientific capabilities of the older telescopes. There is a program there now for speckle interferometry run by Instar and Boyce Astro and probably some other organizations as well that I just can't remember. Sorry about that. But speckle interferometry is a way to look at twinkling stars, make very short exposure, catch them in mid-twinkle, do a few Fourier inversions on them and find out whether you're looking at one star or two stars. And they are going through the Gaia catalog looking for possible unresolved binary stars and have already discovered quite a few. And I'm working on trying to get simultaneous observations with the Chara array, perhaps using a 100-inch telescope, and getting a new telescope from perhaps the Las Cumbres Global Observatory of automated telescopes installed on the mountain so that we can be accessible to everybody everywhere. So we're working on that at the moment. And that's basically what I'm doing.
Oh, that'd be so cool. Ooh. Speaking of work being done at the observatory, so Edwin Hubble has done work on there. So like a lot of people have heard of the Hubble telescope, and Hubble's a very big name, but not a lot of people have heard of the work Edwin Hubble himself has done. And Hubble has done work over at Mount Wilson. Can you tell us more about that?
Yes. Well, of course, Hubble is famous for discovering other galaxies and the expansion of the universe. This image I'm showing you now, which is known as the VAR plate because of the nice big VAR up here in the corner, is an image that Hubble took on the night of 5 to 6 October 1923. He earned his PhD at the University of Chicago, where George Hale, the founder of the observatory, came from. Hale had founded Yerkes Observatory, which is another member of the Alliance of Historical Observatories, and then founded Mount Wilson Observatory. And Hubble came from the University of Chicago with a specialty in photographing nebula. The word nebula is Latin. It just means fog, smoke, cloud, something like that. Anything that's fuzzy in the sky is a nebula. There's lots of different kinds of nebula. But the spiral nebula, which were all relatively large, were the big question mark of the day. And I think Saul had mentioned this earlier in his introduction. Nobody really knew what they were they nearby, were they far away? There was lots of evidence either way. It could have been either one. So Hubble went looking for novae, and you see that they're little black marks with the little dots you can barely see with the ends. And novae are basically little stellar explosions. Material goes from one star, falls onto a white dwarf star, and it kind of blows up. Sometimes they are recurring, but they're never periodic. Hubble found 3 of them in this image, and normally you'd find one in one part of the sky, and maybe a few years later you'd find one in another part of the sky. We can find them more often now because we have bigger and better telescopes, but it's a very big out of the question to find 3 of them in a tiny little piece of sky like this, and concentrated in what appeared to be the spiral arms of M31. So he already knew M31 had to be far away, but he didn't have any way of knowing how far, just far. But then the nova up on top with the big red VAR on it went away and came back and went away and came back and went away and came back and did so periodically. And he realized it was a Cepheid class variable star. And he knew he could use Henrietta Leavitt's discovery of a period luminosity relationship for Cepheids to figure out a distance. So he looked at this star, he went looking for other stars, and finally, in 1925, 100 years ago, coming up this December, he published NGC 6822, a dwarf galaxy in the local group, as a remote stellar system, as something outside the Milky Way. The distances I'm showing you on my slide, the first distance, the smaller one, is the one Hubble published. And of course, today in parentheses, I show you the distance we think it has now. We obviously know a great deal more in the last 100 years about Cepheid class variable stars and how to find distances to galaxies than he knew. So it's not surprising that we would do a better job. He was the first one ever to do it. And when the guy comes first, you got to give him a little bit of credit. So just as Shapley had figured out what the Milky Way galaxy was, here we see Hubble figuring out what the universe around it was, and that it was actually not the entire universe. He published M33 in 1926, and the big one was M31 in 1929. Now, aside from discovering galaxies, he also discovered the evidence for an expanding universe. So simultaneously, in March 1929, with his publication of M31, he published the plot that's here on the left, showing a relative velocity in kilometers per second up on the vertical axis. So going up is faster, and on the horizontal axis is distance getting farther away as you go to the right. And this is the plot that he published initially in 1929. The velocities that he's using up here on the vertical axis come from Vestal Schleifer at Lowell Observatory, and he sort of forgot to mention that, which is a no-no, was then and is now. It caused him a bit of trouble for a while, but he got over it and quickly went to work with Milton Humason. And by 1931, only a few years later, they had extended the distances out to 100 million light years. And you have a nice linear relationship here between the distance and the velocity. Now I'm defining the redshift z down here in terms of the wavelength you're observing minus the wavelength that you would see in the laboratory. And the redshift, in simple terms, is the ratio of the velocity you're plotting to the speed of light. So anything with a redshift greater than 1, and there's a great deal of stuff out there where the redshift way above 1 is apparently moving away from us faster than the speed of light, which seems like it should violate Einstein's relativity, but it doesn't, because space is doing the moving, not the galaxy, and space can do whatever it likes. It's in control, as they say. But I do want to feature this paragraph from the New York Times in 1924. I want to read the paragraph in blue because I think this is actually a very important paragraph in sort of the social history of the world. It reads, "The results are striking in their confirmation of the view that these spiral nebulae are distant stellar systems. They are found to be about 10 times as far away as the Small Magellanic Cloud, or at a distance of the order of 1 million light years. This means that light traveling at the rate of 186,000 miles a second has required 1 million years to reach us from these nebulae, and that we are observing them by light which left them in the Pliocene age upon the Earth." Today, we are comfortable with the notion of the universe being extremely large and things being millions or even billions of light years away. But this paragraph represents, as far as I can tell, the very first time this idea ever appeared in popular discourse. It was privately known to Hubble and some of the astronomers that he had been speaking with, but the broader world simply did not know what he had discovered until this paragraph appeared in the New York Times, which is a completely new idea and is now common in popular discourse, common in popular society. And it begins here and begins with, of course, Hubble's work at Mount Wilson Observatory. And you notice they spell his name, as we might say, wrong, but consistently throughout the article. And several years ago, we had a Hubble family reunion at Mount Wilson with many different spellings of the name Hubble, and this is the way one of those branches of the family spelled it. So it is a valid spelling, as far as I know, of the Hubble family name, and it's spelled this way consistently throughout the article. It's just not the way Hubble himself would have spelled it. Now, he was using Cepheid-class variable stars. Henrietta Swan Leavitt discovered the period luminosity relationship for these stars, which is, the plots down here. I'm going to take a better look at them in just a minute. That she published in 1912. Most people tell the story by leaving out Einar Hertzsprung. Henrietta made a major discovery for sure, but she did not know how far away the stars were that she was looking at. So she could not figure out how to relate that to distance. Einar Hertzsprung did that in 1913 using stars and statistical methods in the Milky Way. So Henrietta discovered this relationship in 1912. Hertzsprung calibrated it in 1913, and then in 1914, Harlow Shapley began using it to make his discoveries about the structure and size of the Milky Way galaxy. And then following on Shapley, Edwin Hubble used the same method to find far distant galaxies. The way it's done is fairly easy. These two plots are plotting the same thing. On the vertical axes are identical. It's apparent astronomical magnitude, dim at the bottom, relatively bright at the top. If you think apparent magnitude 12 is bright, and for some telescopes it is, but on the horizontal axis, on the left plot, it's the days, the period of the star's variability in days. And on the right-hand plot, it's the logarithm of the period, because the logarithm gives you a straight line, which is much easier to handle. And if you notice the equations down here, the top equation, if you remember your high school algebra, is just the slope-intercept form for the equation of a straight line. And if you don't remember your high school algebra, there are solutions to that problem. There are community colleges, online classes, books, self-teaching. Okay, I'm picking on you if you don't know your math. Don't worry about it. But so this big M is the absolute magnitude, and this is the logarithm of the period, which is the number here on the horizontal axis, or the logarithm plotted directly here. Figure out, you can diddle these three, A, B, and C, and move the line around and figure out what this big M is. And then if you take the difference between your apparent magnitude and your absolute magnitude, and the logarithm of the distance shows up, and that's how you turn the magnitude into a distance, because we know that the brightness varies as a function of the inverse square of the distance. And this is a more modern plot of what Cepheids look like. Walter Baade, who was an astronomer from Mount Wilson Observatory and Palomar Observatory, discovered the existence of two different classes of Cepheids. Now there's a whole bunch of different relationships having to do with metallicity and lots of other details none of them could have known about. But this was the big one. And Baade's discovery allowed us to double the size and age of the universe in one stroke, which was a very handy thing to do in the mid-1950s.
So actually, a quick question. What is a Cepheid variable star versus just a regular variable star? Or would they be kind of the same thing?
To some extent, they are kind of the same thing. Stars vary for lots of different reasons. Some are actually eclipsing binary stars, where one star will get in front of the other and make it dim, and then it'll get brighter. Cepheids are a particular class of variable star that expands and contracts. And so their light curve is asymmetric. So they get bright really quickly, and then they get dim over a much longer period of time. And then they start brightening again, and that's between when they start brightening and when they start brightening is one period. And as you can see, the horizontal axis here, they're typical from a few out to no more than 100 days period. There's an ionization instability in the atmosphere of the star that causes it to pulsate. So when it's shrinking and getting hotter, it's getting brighter, and that happens very quickly. And then when it's expanding and getting dimmer because it's getting cooler, even though it's expanding and the surface area is going up, it's still getting dimmer. That takes longer to do. So it's a particular class of variable class star. Anything else?
Oh, that's all. Thank you very much.
Okay. And before I leave you, I turn off my slides or answer questions. I just want to put in a plug for where I am right now. I'm sitting in a room that's off to the right in this picture, and out in front of me there aren't quite as many telescopes as there are in this picture. We never know who's going to show up. Sometimes lots of telescopes show up, and sometimes only a few. But this is a small municipal observatory owned by the city of Monterey Park, operated for it by the Los Angeles Astronomical Society. We open every Wednesday night. So anybody listening to this live stream here in Southern California, you can make your way to Garby Ranch Park on a Wednesday night. You can look up the Los Angeles Astronomical Society. Next year, we celebrate our 100th anniversary, founded in 1926. We'll have a year-long bash. It'll be a lot of fun. If you have like a new telescope, people bring telescopes to us that were given to them or that they bought and they don't know how to use. We show them how to use them. It's a small, very relaxed atmosphere. It's not like Griffith Observatory, which has 10,000 people go there every day. Almost literally, they have many thousands of people every day. They have a great museum. It's a really good science learning observatory. We have a couple of guys, and you can come down here and talk about making telescopes, talk about astronomy in a very relaxed and friendly atmosphere. And with that, I will turn you over to the relaxed and friendly atmosphere of the masters of McDonald Observatory. Thank you.
Well, thank you, Tim. And yeah, so we're going to switch over a view that they're probably having over there, or that y'all might get tonight, and that we're having our telescopes, is a view of the Andromeda galaxy, which I see we have a live view of. So we're going to pull up a live view, and here's a view of M31, the Andromeda galaxy. Now, Andromeda galaxy is very, very big, and this is the same galaxy that Edwin Hubble found, that Cepheid variable star that, as Tim just mentioned, helped us find out that, Milky Way is not the whole universe. It's actually just itty bitty part of it. To give an idea of how big Andromeda galaxy is in the night sky, if Andromeda galaxy was as bright as a full moon, it'll be about 6 full moons across in the night sky. It's actually visible to the naked eye, as in Joe, Ryan, and I could step outside and see it with our naked eye if you want to. It would take a little bit to get our eyes to adjust and do what we call avert vision to look at it indirectly, but we can see it. It's about 2.5 million light years away from us, which will be about 15 quintillion miles. It's about 2.5 times larger than our own Milky Way, containing an estimated of about 1 trillion stars is the current estimate of the number of stars in Andromeda. And with this, so with how close it is, how big it is, we can't fit the entire view in the telescope. But even here, you can see there seems to be lines of clouds in Andromeda. Those are the actual dust lanes of Andromeda. You can see them on the left and right side, those really nice, well-defined dust lanes. we've been doing what we call live stacking. So basically getting the images stacked one on top of another for basically since the start of the stream. So this has been a really nice, good amount of stacking of images, getting us some nice defined views here. And right, it's a really nice view. And that really bright light kind of the top in the middle of the view of Andromeda is the core of Andromeda. And it's so bright because there's just so many stars in here. It's really, really, really nice. It's such a nice view. It's just so pretty.
Very nice.
It is. Ooh. I just want to keep staring at it.
Yeah, you should
But-
try counting the stars. 1, 2, 3, 4. I kind of, yeah.
Yeah, we should. Yeah. Yeah. 1 trillion stars of in Andromeda, and 1 trillion stars. Take one down. Can be something to keep you occupied on road trips.
Yeah, you'd be busy for the rest of your life.
Yeah. Though, yeah, probably. And for the next life, and the one after that, and after that. Yeah. Though, actually, the cool thing as well is Andromeda's not the only thing, well, in the area of Andromeda. Andromeda actually has other things around it, which actually Joe will tell you a bit about.
Yeah. So if you look at the
Yeah.
Andromeda galaxy through a telescope, a smaller telescope, you can fit the whole galaxy in the field of view. You might notice 2 fuzzy things next to it. Those are satellite galaxies of the Andromeda galaxy. There are 2 of them you can see, M32 and M110. So I don't know if Saul mentioned this, but the M stands for Messier, from a French astronomer, Charles Messier, a French comet hunter. He made a catalog of things he wanted to avoid when looking for comets back in the 1700s. And so those pretty easily visible through a small telescope, those 2 satellite galaxies. And there's some other satellite galaxies of Andromeda. A couple of them are kind of faint, called NGC 147 and NGC 285. And NGC is another catalog, new general catalog from a catalog of 7,840 objects compiled by an astronomer, John Dreyer, in the late 1800s. And these satellite galaxies are typically dwarf galaxies, very small compared to, say, the Andromeda galaxy. And they average a few 100,000 to maybe 1 million light years away from the Andromeda galaxy itself. In fact, the Milky Way has some satellite galaxies. These are called the Large and the Small Magellanic Clouds. And you can see them best in the Southern Hemisphere, like Australia, South America. And I took a trip to Australia about 10 years ago and saw them. If anybody's seen the Magellanic Clouds, just, give a shout out about that in the chat somewhere. And the Magellanic Clouds, they're about the Large Magellanic Cloud is about 160,000 light years away, and the small one's about 200,000 or so light years away. And they were reported by some 16th century Italian authors saw these galaxies, reported them, and they're of course named after the explorer Ferdinand Magellan. And the astronomer John Herschel, he studied the Magellanic Clouds from South Africa from 1834 to around 1838. And if you see them in the sky, like say from Australia or something, what they look like are pieces of the Milky Way. They kind of broke it off and are apart from the galaxies. So so Magellanic Clouds, satellite galaxies of the Milky Way, and the Milky Way and the Andromeda galaxy, one called M33, are all what we call the local group of galaxies, which we'll talk about here in just a little bit.
Yeah. And the really fun thing, sometimes these dwarf galaxies can actually become part of those larger galaxies. They can actually consume them. And one of my favorite astronomy terms I usually tell people, your fun science vocab word of the day, when a very large galaxy consumes one of these smaller galaxies, that's known as galactic cannibalism.
In fact, M32 might have been a lot larger, and it was partially cannibalized by M31.
Oh, that is a really fun fact.
Yeah.
Yeah.
I think our own globular cluster, Omega Centauri, is almost certainly the core left over from a gobbled up galaxy.
Yeah.
Right.
Oh, and if y'all want to know more about globular clusters, we do have one of our previous live streams talks a lot about those globular clusters.
Oh boy.
And some little info about the galaxy we're about to see. It's almost ready. Is M32. It's an elliptical type galaxy. It's a little bitty right now, about 8,000 light years across. It has a very dense core. About half the stars are located in the inner core, being about 330 light years across. And it's very, 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 very quite small.
I find it a very nice object to look at in the 60-inch or 100-inch telescopes because M31 is so big, you just kind of see the center of it. But when you look at it from here, you're actually looking through M31 spiral arms in the foreground. M32 is behind it. And it makes actually for a really nice looking object. If you happen to have a 60-inch telescope in your backyard, okay, if you don't, but you can still see it. There's no reason why not.
Yeah, I think we've looked at it with our 82-inch telescope before.
Good. All right, since we got the live view ready, so gonna bring that up. All right, let me bring that up. There we go.
Nice image.
And nice and elliptical type galaxy. So most people are familiar with the spiral type galaxy. So you got your nice spiral type arms, kind of like with what I have on behind me on the green screen. But there are also elliptical type galaxies, which are more kind of like clusters of gas, dust, and stars. Which these some satellite galaxies are. And it's quite a nice view of it. And also you got some nice stars here. Then these stars are still within our own Milky Way. Yeah, if these stars were not within our own Milky Way, these are probably some ginormous stars if they were the same distance as the galaxy. Yeah, it's a nice little view.
You can see the brightness gradient from lower right where it's dark to upper left where it's bright, where you're looking. Of course, you can't really tell whether M31 is in front or behind, but it's in front. But it makes for an interesting view to see the gradient of brightness across the image.
Yeah, and actually you can still make out a bit of like the dust lanes of Andromeda as well. If you notice, like, yeah. Almost seems like you gotta like clean the telescope a little bit, the mirror. Yeah. And actually these dwarf galaxies are not the only galaxies kind of nearby us. There's even other galaxies. So while we start getting our telescope prep for the next target, gotta mention some of the other galaxies around us. So as I just said, the dwarf galaxies are not the only galaxies near us. There's several galaxies around us. So there's actually the galaxies can actually be grouped together in galaxy groups. Astronomers are very literal when it comes to naming things. So our own galaxy group is known as the local group. This term was actually coined by Hubble back in 1936 in his book, The Realm of Nebulae. Our galaxy groups usually have about 50 galaxies in that group. That includes the dwarf galaxies. Our own galaxy group has about 80 is the estimate, give or take a couple of galaxies. And we're kind of finding more as time goes on. So there's even some estimates that say there could be up to 100, but right now 80 is the current estimated amount of members in our galaxy group, most of them being dwarf galaxies. But there actually are some larger galaxies in our own galaxy group. One of the ones that we'll be seeing that is visible right now, the next largest member, is called MESI 33, the Triangulum galaxy. Now, this galaxy is about 2.73 million light years away from us, getting to about 61,000 light years across. It was first discovered in 1654 by Giovanni Battista Hodierna and was identified to be a spiral nebula, so similar to an Andromeda, by Lord Rossi in 1850. And actually, Edwin Hubble classified some cepheids in this galaxy in 1926. So actually, actually even before Andromeda. But Andromeda was kind of like the big one that kind of inspired lots of the further discoveries of the Milky Way not being the entire universe. And the Triangulum galaxy is not the only larger galaxy in our galaxy group. There's another one called Barnard's galaxy. Sadly, it's not visible right now, but Joe actually did get a really nice picture of it a while back, and he did send us a picture. He did send me the picture of it. So while we're getting the stacking going, so we can get a nice view of M33, let me pull a picture of Barnard's galaxy.
Mm-hmm. And
So
yeah.
Oh yeah, go ahead, Joe.
No, I was going to say that's a picture I took with my telescope. So, and that's like a equivalent roughly of a 3.5 hour exposure. And using a specialized astronomy camera. It's an ASI 2600 made by a company called CWO. It's kind of a bigger brother of the camera that we're using.
And you might want to mention that M33 is the only other spiral galaxy in the local group besides the Milky Way and M31. And it's the third largest. Everything else is smaller than M33. So you can find movies of the impending collision between Milky Way and M31 that feature M33 just kind of watching from the outside and not being involved. That's where you want to be when the galaxies collide. Go to M33. You'll be safe there.
Yeah, M33 is like, I don't want to get involved in that. Yeah, but thank you for mentioning that. Yeah. Oh, and also involving the collision of M31 and the Milky Way, some numbers that got updated recently is with that collision. So that collision will be happening in about 5 billion years. So make sure to mark your calendars. And that now the collision, there's about 50-50 chance of that happening. Some other cool things about the collision, when collisions happen between galaxies, it's like if clouds of smoke got blown into each other. They get blown into each other, swirl around, drift apart. But there being gravity, they get pulled back in, swirl some more, and keep going till they fully fuse. One of the proposed names for the newly fused galaxy will be Milkdromeda. I'm not a fan of that name, but hey, we got 5 billion years for a new one. Now going back to Barnard's galaxy, the galaxy is about 1.6 million light years away in the constellation of Sagittarius, about 9,200 light years across, and it's actually the first galaxy to be that Edwin Hubble published. So it's actually also fits in his work. So it's actually lots of cool history tonight. Oh, and I see that the live view for M33 is ready. So let me get that pulled up.
Yeah, answering Michael Rudy's question, it is a dwarf irregular galaxy.
Yeah.
Yeah, dwarf irregular.
Yep. Awesome. And that's for Barnard's galaxy, because you can see for M33, it's very, as Tim mentioned, M33 is very much a spiral galaxy. You can see the nice spirally arms in it. And I also really like the galaxy because it looks so glittery, so sparkly.
Somewhere in M33, and I can't remember the NGC number, and I don't think is the largest H2 region or star formation region in the local group. It's the equivalent of the Great Nebula of Orion. But if you put it where the Great Nebula of Orion is now, in our sky, it would be 50 degrees across. It would be enormous. And I don't know that it shows up in this picture or not, because I don't remember exactly where it is in the galaxy, but I know that it's in M33 somewhere.
Yeah, NGC 604.
Ah, okay.
Ooh, it's such a nice image. Ooh. I really wish I could just be staring at the image.
100-inch. Okay. And M33, you might see it on a dark night away from city lights, possibly with your eyes, but in binoculars, it looks like a big kind of fuzzy thing.
Yeah, a lot of these objects are, as kind of Joe mentioned with the Mezzi objects, they were seen as fuzzy things with like smaller telescopes and binoculars.
I think it's ironically worth pointing out that Charles Messier, he sold comets for a living, the right to name them. So this famous list of Messier objects everybody studies and everybody looks at is the list of things he hated and never wanted to look at again for the rest of his life, because they got in the way of finding comets. And that's what he's famous for. Everything you didn't want to look at, but you got to be famous for something. So kudos to Messier.
Yeah, I mentioned a lot of the programs. Like his like "Don't Look Again" list is the most famous. So one thing, so we saw lots of really cool galaxies that are part of our group, but as I said, there are galaxy groups out there. There are other galaxies out there, and there actually is another really cool galaxy that we can see tonight. It's actually our last target of the night. And while we get that pulled up, gonna talk a little bit about that. Our final target of the night is a galaxy known as NGC 7331. So before I talk more about this target in specific, there are the other galaxy groups out there. So the galaxies can have enough gravitational influence on one another that it can be in these galaxy groups. But there are not only galaxy groups, there are even galaxy clusters and galaxy superclusters. There can have these gravitational influences on one another. For example, our own supercluster is known as the Virgo supercluster. But that will probably be something for another night's program. For tonight, we're talking about galaxy groups. NGC 7331 is known as the Deerlick galaxy group. And the NGC 7331 is a really pretty galaxy. It's getting to about 43.79 million light years away from us, about 146,000 light years across. For a while was known as the Milky Way's twin, until we started having better ways of measuring how large the galaxy was. And we found that it's not really the right size to be a twin, but hey, it's still a spiral type galaxy. But the other really cool thing about the galaxy, especially recently, is that a supernova occurred in the galaxy back in July of this year. That supernova is called SN 2025 RBS. Really rolls off the tongue. Now, the way we get the naming of the supernova, so SN for supernova, 2025 because it was discovered this year. And for the letter, it's the order it was discovered. For example, the first supernova of this year is SN 2025A. Second one, SN 2025B, then C, and you keep on going. Once you run out of letters, you start adding them on. So SN 2025 AA, SN 2025 AB. And if you want to just keep going, SN 2025 AAA, 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 just kind of can keep on going if you run out of those letters. So kind of right now, we're an RBS. That's just how it is in the naming schematic of it. And was now over the time, it has been getting dimmer and dimmer and dimmer, but it is just it is actually still, we're hoping to see if we can get a glimpse of the supernova, see if it's bright enough to actually see the nova in here. So we'll see if that is visible. So we're seeing the image kind of being processed a little bit right now. So if you can see, like here we have, this is just by this photo by Adam Block at Mount Lemmon and University of Arizona. It's just how NGC 7331 looks normally, no supernova in view. Those galaxies you see behind it are getting to about 300 million light years away from us. So getting a good way further out. Let's see, I think we got a live image coming on out. So let's see how that is. So let me bring that up. Let's see. It's a little bright right now.
Okay, yeah.
Yeah, might be a light cloud coming in.
Ah.
Oh, it's getting a little dark. There it goes. So the cloud might be moving away.
Very good.
Yeah. Ooh. Let's see. But we are getting a really nice disc shape in there. See, but yeah, they're actually looking very nice. So you're getting the really nice bright core in there. See, ooh, yeah, I think definitely there was a cloud in the way there. Ooh, that is a very nice live image.
Lots of detail.
Yeah. And see, Ryan, see if you can, if it's possible to scroll down a little bit or zoom out a little bit if possible. Not sure how zoomed in or out we are currently in the software.
Ooh, oh, there we go.
Nice, thank you.
Whole thing. There we go.
Ooh, yeah, there definitely was a cloud in the way. We're seeing it get darker and darker. Ooh, that's nice. And actually, yeah, I think it's in the 12 o'clock view, or actually would that be like 10 o'clock? Would that be the nova there? Looks like a little star there.
Possibly.
The supernova, better yet? I should.
Yeah, supernova.
Supernova. Yes, not the nova. The supernova.
Orient myself here. Could be.
Yeah. So sometimes one of the little problems when we're observing from within our own galaxies is the stars in our own galaxy can get in the way. Yeah, this actually is a very nice view of the galaxy. Yeah, so supernovae in other galaxies can appear like, hey, a random star just appeared in the galaxy. That actually was similar of how supernovae look like from here on Earth when they occurred in our galaxy. For example, in 1054, many civilizations on Earth report seeing a sudden star appearing in the sky that was so bright it cast shadows for several weeks. And turned out that was a supernova. And many cave paintings and such that have been discovered over years have mentioned guest stars appearing in the sky. There are also supernovae. So one of the ways we end up knowing, like, hey, a galaxy has a supernova is there wasn't a star there before. Now there is a star. Yeah, but I do think that might be the star kind of to. I want to see the star kind of like to 10 o'clock ish, maybe.
Yeah.
Yeah, though actually we do have some other pictures for comparison as well. So actually, Joe took a picture of the galaxy. When was the picture that you took, Joe?
About a month ago.
Yeah, so the picture from a month ago. So
Hmm.
for comparison, here's a picture that Joe took about a month ago of NGC 7331. So, so in here, and the software we're using also compared with OBS has mirrored the image a little bit. So in Joe's image, the supernova is towards the bottom. So when we put the arrow in, here we see it. And even from further back, actually a bit over a month ago, on the 82-inch telescope, one of our colleagues, Judson, actually was able to get a picture of NGC 7331 with the nova in view. Like, it was actually bright enough that he was able to put his phone onto the eyepiece and get a picture of NGC 7331. And he could actually get the supernova on his phone. That's how bright it was.
Hmm.
And when we've done programs on the 82-inch telescope, people have been able to actually see the supernova in the galaxy. And as we've been doing our programs, we have been able to see that it's been getting dimmer and dimmer and dimmer and dimmer. Oh, there's a good question. What is the safe distance for us to be from a supernova?
I think there was a paper, a fairly extensive study on that not long ago. It's closer than you think. It's like 10 light years. 100 is certainly far enough away. So probably if you're 10 light years away, you're okay. You have to be really close to one of those to get fried. Now, gamma ray burst is completely different because they're channeled bursts, and so if you're in the channel even a long ways away, you get into trouble.
Yeah, thank you, Tim. And yeah, that sounds right to me. I do remember it being like surprisingly close. It could be to a supernova. Let's see if in the other ones. Oh, an earlier question of, I believe an earlier question that came in of how much larger Andromeda galaxy is to the Milky Way. That the answer to that is the Andromeda galaxy is about 2.5 times larger than the Milky Way.
Yeah, I don't believe that number. I'm skeptical of that claim. I think the two galaxies are about the same size. It's really hard for us to tell how big the Milky Way is because we're inside of it. It's a lot easier to look out at a galaxy and there it is. It's the big thing. We're in it. And how do you see the end out there? So I know everybody thinks it's bigger, but I'm skeptical about that. So I'm going my own way and arguing they're about the same size.
Yeah. Oh, and I see another comment came in saying that maybe we are larger than Andromeda. All right. Let's see. All right. So I believe that's all the targets that we have tonight. See, are there by chance any questions that anyone has? Now's the time to ask any of those final questions if they have any. Let's see. Speak now, forever hold your peace. A comment did come in, Tim, saying that you were Space Gandalf, which I found very appropriate since you said there was a picture of you on the website dressed as a wizard.
Yeah, the slightly older people call me Gandalf. The young people call me Dumbledore. And if you're really old, I'm ZZ Top.
Oh, question from Alex McConnell. When do we go live again? So we're playing our next live stream for around mid-December. So if you follow us on social media, so Facebook, Instagram, and so if you follow just our social media, just our Facebook and Instagram, you can see those updates. But our next currently planned live stream is for mid-December. Also, for those of you who are joining in late, this live stream is saved to our YouTube channel, just McDonald Observatory on YouTube. And we've done over 70 live streams from galaxies to star clusters, books we recommend, the sun, some other historical ones. So we definitely recommend just checking those out. Oh, a nice, cool final question from Jay. I'll ask one. Why are supernovas bright for a few days or weeks instead of just a flash? Tim.
Well, what's happening is there is a great deal of radioactive decay of heavy nuclei in the expanding envelope. And so the initial flash is the supernova, but then that dimming for a long time is the decaying of these isotopes in the expanding shell. The ones with a shorter half-life, of course, they go away quicker, and so you get things cooling off, dimming along some curve. That's the basic reason why they stay bright for so long.
Awesome. Thank you so much. Right. Let's see. Believe that's about all the questions and also all the time we have. Thank you all so much for joining us tonight. If you're interested, so the McDonald Observatory and Mount Wilson are open to the public. If you want to know more about our respective programs, check us out online. So for McDonald Observatory, mcdonaldobservatory.org, we do recommend making reservations. Also for just our live stream programs, check out our social media pages and McDonald Observatory on YouTube, and make sure to like and subscribe to our YouTube channel and leave comments and share. The engagement does really help. And for Mount Wilson, where should they go to find out more about Mount Wilson's program?
Well, Mount Wilson's webpage, mtwilson.edu, and some of the images I had at the beginning of my talk were just frame captures from the webpage. So there's all the information you need about how to go to the art shows, the lectures, look through the telescopes, tours, whatever it is you like to do is there on the webpage.
Awesome. And thank you so much, Tim, for joining us tonight. That was awesome having you on the stream, and hopefully we can do more of these in the future.
Thanks for inviting me. You're lucky. I gave a talk at Mount Wilson that lasted 4 hours, on our science. And so, you guys got off light.
Hey, maybe in the future we can do we can do a marathon, just go back and forth, see who drops first.
So far I've been able to outlast everybody, so I'm up for it.
Right. Well, thank you everyone for joining in tonight, and hope everyone has a good night.
Good night indeed.
Good night.